Hi, I'm Carys. I'm a senior developer at Shopify where I work on data viz among other things. I just have a really quick talk today about how I used high school math in the last few weeks to fix some label issues on some charts. So these were the kinds of issues that I was fixing. I was making some charts that had really only been used for one purpose. I was making them a lot more reusable, which meant that I needed to figure out how to deal with super long labels. These are a bit exaggerated here, but I needed to find a way to deal with labels that might be cut off by the side of the chart. This is particularly important for us if we are rendering a chart in a language other than English where the strings might not be what we expected. So some of the things that I needed to figure out in order to get the layout right were what exactly should you do with super long strings on a chart. So that's the strategy that's mentioned there. Before you start actually coding things, it's always a good idea to figure out exactly what it is that you're trying to do. And then I had a list of sort of different data points that I needed to be able to get the chart right, the layout right for the labels. And all of those ones in bold we're able to solve through the magic of high school math and trigonometry using right angle triangles. So I will show you a couple of quick examples. So here you can see on my bar chart, I've kind of drawn on the right angle triangle that helps me figure out some of the missing measurements that I need to be able to get those labels right. So the hypotenuse in this case is my label, which I want to be able to truncate when it gets too long, when it's going to be cut off by the side of the chart. The adjacent side is the top, where you can see where the x-axis would be, and it ends where the middle of the first bar is. And then the opposite side is the one that's running from the top of the adjacent side to the bottom of the hypotenuse. And so what's interesting about this is that the adjacent side I can actually really easily find. These charts are made using D3, so I can use some D3 methods to be able to get the width of the bar, and I can figure out how big my y-axes will be depending on how big those labels are as well, in order to be able to figure out how big that space actually is. Then in terms of the hypotenuse, we'll get into that more later. That's where some of the magic high school math comes in. And the opposite is the max height of the angled label. And we know that angle in the corner, where you can see it says 40 degrees, and we know that angle because that is the angle that I'm rotating my labels by when they get too long. So now you can see the magical high school math is coming into play. I know that this is probably giving people flashbacks to high school and having to remember SOHCAHTOA and all these acronyms. I promise you it's probably not as painful as you remember. So in this case, basically what I was able to do was use cosine, since we have the diagonal angle, and the adjacent side, which is, if you remember, the top part that I was able to calculate when I know the y-axis width and the width of the bar. And then you can see my JavaScript code here. So basically what I'm doing is figuring out where the middle of that bar is, and then the distance to the first tick. And then my rejigged cosine formula is basically to divide the distance of the first tick by math cosine and the diagonal angle. And fun fact, if you're working in JavaScript, you need to convert your regular degrees to radians. So that's what my utility function there is doing. And then here's just another really quick look at using Pythagorean theorem. So very similar, now that I've figured out two of the sides, I'm able to figure out the other one. So in this case, I've figured out the hypotenuse based on the information on the last slide. And then I need to know the opposite length, because that is how tall my x-axis label space needs to be. So I'm solving that using sort of a JavaScript version of Pythagorean theorem. And just a fun tidbit to end on is that JavaScript actually has a hypotenuse method on math, which I was super surprised by. Thanks.